All right, this is section 1-4, and this is titled Reactions. In part 1, we are talking about something called oxidation numbers. And in this reaction section and in the next section, which is redox, this is going to be an important thing that we need to look for. So, if you're looking at the front page, there are 3 rules here. And the description is the oxidation number, or the oxidation state, synonymous terms, is the, quote, apparent charge of an atom if shared electrons are assigned to the more electronegative atom. So we can figure these out based on a certain set of rules. So rule number 1, and I won't write out the whole thing, it says the oxidation state of elements is 0. And the oxidation state of monatomic ions is its charge. So some examples. You have calcium, you have nitrogen gas, and you have oxygen. So the oxidation state of an element without a charge is 0. Change colors here. 0. The oxidation state of a nitrogen that is an element is 0. Oxygen O2, this is the elemental form. Oxidation number is 0. If you have a monatomic ion, it is the charge. And this leads right into rule number 2. Break up ionic compounds into their components. So we're looking at monatomic ions here. So we have calcium 2+, we have nitrogen 3- and oxygen 2-. So their oxidation numbers are based on their actual charge. The oxidation number of calcium with a positive 2 charge is +2. The oxidation number of nitrogen ions, -3. And the oxidation number of oxygen ions, -2. Now you might notice that when I write charges, it's always the number and then the sign, which is typical for charges. But when we talk about oxidation numbers, it's the exact opposite. It's the sign and then the number. This is just the system that's used. I'm not sure how this came about, but this is just the typical way to describe it. Rule number 3, the sum of the oxidation states of all the atoms in a covalent compound or polyatomic ion is equal to its charge. Assign oxidation states to atoms in this order. Fluorine has an oxidation state of -1. That one takes precedence over everything. Next off, oxygen has a state of -2, and peroxide is -1. And hydrogen has an oxidation state of +1. Unless it's in a hydride, it's -1. But we can generally say hydrogen +1. So we have calcium oxide, we have calcium nitride. So break up ions into their components. So what we really have here is a calcium 2+ along with an oxygen 2-. And their oxidation numbers are +2 and minus 2. This is a neutral compound, and so their oxidation numbers need to equal 0. Plus 2 and minus 2 equals 0. This would be a neutral compound. Calcium nitride. So calcium, we have Ca2 plus. Nitrogen, we have 3 negative. And so the oxidation numbers here individually are plus 2 and minus 3. But if you total them out, so you notice that each calcium is plus 2, so you would have positive 6 and negative 6, which ends up being that neutral compound like we need. But the oxidation number of calcium is expressed in terms of a single ion, just like nitrogen is a single ion. So we do not want to write plus 6 and minus 6. We want to keep it in terms of individual atoms, individual ions. For some more examples, we have NH4 plus, that's ammonium. So looking at our rules, hydrogen would be the first up. Hydrogen has an oxidation number of plus 1. And overall, this compound has a plus 1 charge. So 4 hydrogens, each one's plus 1. That would be plus 4. To make this have a positive 1 charge, nitrogen is negative 3. Again, if you totaled it up, you'd have negative 3 plus positive 4 equals positive 1, which is good. But we're going to express it in terms of individual ions, individual atoms. Dinitrogen tetroxide. The oxidation number of oxygen, negative 2. The oxidation number of nitrogen here is not going to be its negative 3 like in the previous examples. We have to figure this one out. So overall, this is a neutral compound, its charge is 0. So what we have is negative 8, and we want this to equal 0, which means we have to have a positive 8. With 2 nitrogens, that makes each nitrogen have plus 4 for an oxidation number. HNO3, nitric acid. So the rules say that we look at oxygen first, negative 2. Then hydrogen, there's plus 1. And overall, this compound is neutral. So we have plus 1, we have something for nitrogen, and all the oxygens make minus 6. And so we're looking for basically solve for X if you have to do it this way. And so we find that X equals 6 minus 1. It's plus 5 in this example. Oxidation number of nitrogen is plus 5. We've got nitrogen monoxide, dinitrogen monoxide, and dinitrogen tetrahydride. So for this one, oxygen takes the precedence, it's negative 2. to make all of this equal 0, nitrogen is positive 2. In this one, oxygen is negative 2, which means that we have to have a total of negative 2 for nitrogens, a total of positive 2 for nitrogens, which makes each individual nitrogen plus 1. Over here, hydrogen comes before nitrogen. Hydrogens are plus 1. That would make this side plus 4, which means this side needs to be negative 4. 2 nitrogens makes it negative 2. All right, so just a few more examples. We have calcium nitrite, ammonium nitrate, and calcium CaO2. So let's look at these. Calcium is an ion, and here it has a 2+ charge. It means its oxidation number is +2, and there's only one of them. Overall, nitrate has a -1 charge, and so we have to look at this one. So let's see here, nitrite. We end up with -2 for the oxygen, and the charge of this ion is -1, which means we need to have +3. Total for the oxygen is -4. This is +3. That makes this whole thing -1. 2 of them would make it -2. So this is how we find the oxidation numbers. We'll talk about this more in class, and it'll help to clear things up here. For this one, we are looking at our 2 ions individually. So we have here +1 for hydrogens. That makes all of this +4. To make it +1, we just need a -3. This other nitrogen is probably going to have a different oxidation number. It's a good possibility. So each oxygen should be -2. Charge of the compound is -1. 3 oxygens with an oxidation number of -2 is -6, which means nitrogen needs to be +5. Lastly, we have CaO2, and generally oxygen takes the precedence, but we have to look at this in terms of charges. So the first thing we're going to look at is calcium is generally +2, so its oxidation number is its charge, which means that the oxygen here is going to be a little bit weird. This is going to be your unusual oxygen situation, where each one has a -1 oxidation number instead of -2. Okay, so right below that there is a chemical equation. And the instructions say find the oxidation numbers for each element in the following reaction. So taking a look at these, copper is in its elemental form. It has no charge. Its oxidation number is 0. And the next one, oxygen is -2. This is a nitrate. So its overall charge is -1. So here's -6. Nitrogen needs to be +5. Hydrogen will be +1. Over here, we have nitrate and we have 2 of them. Each nitrate has a -1 charge, meaning that all of this has a -2 charge. So copper is +2. Oxygen is -2. And again, nitrate is going to be the same as it was here. Nitrogen is +5. Over here we have oxygen, which is -2, which means this nitrogen is +2. And then for the water, we have oxygen -2, hydrogen +1. And so that's how we go through and figure out our oxidation numbers for each chemical, for each element in a compound in a reaction.